All right, so these three questions is based on the concept of determinants of matrices and the matrices themselves being singular. A singular matrix means that the determinant would be equal to 0. So that's the key characteristic that we have to use in order to solve these questions, right? So let's look at number 1. That's our second, eh? Right, so first one, N is the singular matrix, 4, 2, 3, 5. Find the value of K. So N is singular. So the determinant of N is going to be equal to 0, right? So N is 4, 2, 3, K. I always like to equate it A, B, C, D. So when I quote my formula, AD minus BC. Easy for me to look up here and see what I'm multiplying. So 4 by K minus 2 by 3. So I get 4K minus 6. Now, since it's singular, N, determinant N is equal to 0. So 4K minus 6 is equal to 0. So what that will mean is that 4K is equal to 6. And K would be equal to 6 divided by 4, which is 3 over 2. Right? So that's number 1. Very easy. Number 2. We have Z is equal to 3, 5P, 15, and P cubed. 5P, 15, and P cubed. Right. So let us put that equal to A, B, C, D. They say to write down the determinant of Z. Calculate the values of P, which make the matrix Z singular. So the determinant of Z is going to be A by D minus B by C. A by D. A is 3. D is P cubed. B is 5P. And C is 15. So we get 3P cubed minus 50 and 25, 75P. Right? Then for part B, when Z is singular, it means that the determinant is equal to 0. So 3P cubed minus 75P is equal to 0. Now, what you'll need to do for this, you'll have to bring in some of your algebra skills. So let's factorize this, right? If we factorize this, we could take out 3P and we remain with P squared minus 25 is equal to 0. So separating that, we could have 3P is equal to 0. In that instance, P would be equal to 0 divided by 3. P is equal to 0. Then we could have P squared minus 25 is equal to 0. Right? We move the 25 across the equal sign and become positive. We move the square. We find the square root of 25. I remember the square root of 25 will give us plus or minus 5. Right? Because plus 5 by plus 5 will give us 25. Minus 5 by minus 5 will give us 25. So values of P for which Z is singular would be 0, 5, and negative 5. Yeah? Everybody good with that? Well, thumbs up if you are. right? So doing the last one now. Given that M is equal to 3, B, 1, and A, calculate the determinant of M and a pair of values of A and B such that M is singular. So 3, B, 1, and A. So M is equal to 3, B, 1, and A. Sure, I write the correct thing as it's. As usual, I would equate this to A, B, C, and D. We want to find my determinant, put my formula, AD minus BC. M is going to be A is 3, D is A. B is B, and C is 1. So again, 3A minus B1, right? Or 3A minus B. A pair of values, so any pair of values that you could think of that will make M singular, right? So what you have to do is to select any two values that you could substitute for A and B that will result in us getting 0. So for example, this is not a solution like the other. 3 by 2 will give me 6. And if B is also 6, then I'll get 0. Right? Another example could be 3 by 4 will give me 12. Right? And 12 minus 12 will give me 0. Another example could be 3 by 5 will give me 15. And 15 minus 15 will give me 0. Everybody understand the concept there? Yeah? All right.